Alright, in this question, Abby made an input-output machine that uses two operations. Here's the table on the right. Find out what the machine does to each input number. So that means we got to figure out what numbers and what operations are inside that machine. If you look at the chart, it looks a little strange. It seems all jumbled up. So what we need to do is put it in the correct order. So I would rewrite it, put the smallest number at the top, and then I'll just kind of scribble these out so that we don't see them, so they don't confuse us. And now I've got my input-output chart in the correct order. Alright, and I try and look for a pattern. Well, there's something that we learned last lesson or last video. It was to look at the output and see, is there a pattern there? And I do see a pattern. I see it going up by 1 each time. Okay, now as I said before, there's a little hint that might help us, and it's usually to take the pattern that you see, in this case it's 1, and we could try and do a times 1 and see if that helps us. But just by looking at it, I can tell right away that isn't going to work, and I'll prove it to you. It isn't going to work 100% of the time, this little hint. Okay, so the hint is you look at the pattern that you get in your output. In this case it's going up by 1, so you could try a times 1. But I know it's not going to work automatically, because I know that if I go 5 times 1, that's 5, and I'm supposed to be able to get to an output of 4, and well, I'd have to do a subtract 1. It'll work for my first input, but it will not work for the second one. So look, if I do a 10, 10 times 1 is 10, and 10 minus 1 is 9, and that is the wrong output. I'm supposed to get a 5. If I have a 10 as an input, I'm supposed to get a 5 as an output. So obviously that little hint that we talked about last video didn't work for this one. But I tried it, just in case. So I'm going to start again, and I'm going to think, if I look at my inputs, I start at 5 and it goes up by 5 each time, and my outputs start at 4 and go up by 1 each time. So since my outputs are less than my inputs, that's a hint. To me, I'm probably going to use division or subtraction. Okay, that's the only way that you can get a smaller number on your output. So I'm going to rewrite my machine. This is just a basic guess, kind of thing. You got to test some of your guesses. It's called guess and test. Alright, that's my strategy. So if I start with a 5, I'm going to try a divide. I'm going to divide by, well, since 5 is not an even number, I can't divide by 5, and I can't divide by, I can't divide by 2, and I can't divide by 3, and I can't divide by 4. I could divide by 1, but I don't know if that would help us. I could try it. If I divide by 1, and remember, I'm supposed to get to an output of 4. So 5 divided by 1 is actually 5. And then 5, to make it turn into a 1, I would have to have a subtract 1. That'll work for my first one, but I know it's not going to work for my second one, because if I have 10 divided by 1, that's 10, and 10 minus 1 is still 9. So that didn't work, but I could try to divide it by 5. Okay, so I'm going to try divide it by 5. 5 divided by 5 is 1. And to change a 1 into a 4, I'm going to add 3. That works for my first input. But let's try the second one. We're going to double check. 10 divided by 5 is 2, And 2 plus 3 is 5. Hey, that checked out. And I can try my third input. 15 divided by 5 is 3, and 3 plus 3 is 6. It checks out. Okay, so I have just figured it out. My input-output machine is a divided by 5, and it is a plus 3. So, divide the input by 5 and then add 3.